Welcome. In this lesson, we will demo semantic vector memory. We need Redis database for this. We'll use cloud-based free tier. We have a separate lesson for entity knowledge graph. So we will cover this entity knowledge graph demo separately. Now let's look at the dependencies needed for this demo. We need two dependencies. One, Spring AI starter model chat memory repository Redis. Another one, Spring AI Redis semantic cache. We also have to configure Redis related properties. Spring data, Redis, host, port, and the password. Let's set up a Redis database in the cloud. Let's move to redis.io try free. You sign up first, then log in. Click on the databases, then click on new database, select free. Then you can change cloud vendor region as you need it. I'll update database name, database Spring AI, and click create database. Wait for a few seconds. Now this is host name. Let me copy and paste it in the configuration. And this is port. To get the password, click on connect, and if you come here, this is default username, and if you click on this icon, you'll get the password. Copy it and paste here. As we use embedding in semantic search, this base URL from Grok doesn't support embedding. So we will be using Olama along with this base URL. Let me configure few Olama properties. Base URL for Olama and embedding options model. I'm using this one. Let's navigate to olama.com and search the model. Its size is 670 MB. Copy the model name, bring up the terminal and do Olama pull and then model name. I already pulled it earlier. If I do Olama list, I should see this model. To use Olama, we need the POM dependency. So let's uncomment this commented Spring AI starter model Olama. Now we have two starter model, Olama and OpenAI. So Spring Boot auto configure now complain about conflicting bins. Now we have to exclude embedding model from OpenAI and chat model from Olama. Let me add those properties. Auto configure, exclude. We are excluding Olama chat auto configuration and also OpenAI embedding auto configure. I think now we are okay with properties configuration and dependencies. Let's now move to coding. Let's define a Redis config new file, Redis config.java. Let's mark it as configuration. Let's import annotation. Now let me copy paste two bean definition here. One is Redis pooled, another one is Redis vector store. These are the properties which we configured for the Redis host, port, and the password. Using that, we get Redis pooled that we use it here in the creating Redis vector store bin. This is the embedding model which we configured here. Now you can change this index name to whatever you want and even the prefix. We are creating a metadata field here with name answer and field type text. I will explain this when we use it in the controller. Now let's create a controller Redis Cache controller.java. Let me annotate this with REST controller. Let's define two private fields, one chat client and another Redis vector store. Let's define a constructor. So if you remember earlier, we used to pass system instruction when we invoke the LLM, but now here when we are building the chat client itself, we are passing the system instruction. Let's define a get mapping agent chat redis. Now define the method which returns string chat with redis cache, which takes a request parameter of type string message. To measure how long it takes to retrieve cached response and also the response from the LLM call, let's define start time. Now get the list of document from the cache. Redis vector store, similarity search, search request dot builder query message. We only need top one from the similarity search and then build. So these method calls will hit the Redis vector store and query the message what we received in the API call. This is a similarity search. So this will not look for exact message. It will look for a similar. Now let's do a if check whether result is not null and result is not empty. If it is not null and not empty, then we have a similar query already in the Redis cache. That means in this case, we will not hit LLM, we will return the response from the Redis cache. Let's implement the logic document doc result dot get 0. Let's get the score of this similarity score dot get score. So if this score is greater than equal to 0.09, so if score is equal to 1, it will be considered as exact match. Let's keep if the score is greater than or equal to, it's somewhat similar to the request parameter message. So if it is not greater than or equal to 0.9, then we'll hit the LLM to get the response for this message. Now get the response, that is cached answer dot get metadata dot get answer. Now we have to cast the data type to string. If you remember this answer what we have configured here in the metadata field. Let's continue with the implementation. Let's check for the elapsed time and return string format. So we are sending elapsed time and we are saying it is a semantic cache hit and this is a cached answer. Now semantic similar search didn't give any result. In that case, we'll call the LLM string response chat client dot prompt dot user, and then we pass the user message from the API call and then call, then content. We can add chat options like temperature here. Once the response is received, let's add it to the Redis vector store, list of new document, message, map of, answer, and then response. Now let's return the response. Something similar to this one. Instead of cached answer, we are sending the LLM response. This is not cache hit. This should be LLM. Now let me build. And run. Let's navigate to the Redis cloud and make sure we do not have any previous data or cache so that we can start fresh. Now navigate to Postman and hit API agent chat Redis. Agent chat Redis with message tell me a Redis joke. When we hit the API now, we do not have any cache. Let me hit the API and this much time in milliseconds and response is from LLM. Go to the Redis Cache, refresh the page, and you can see it here. Let me hit the API again. Now response should come from cache. See here, and see the elapsed time. It didn't hit the LLM, so it is very less compared to the previous elapsed time. And you can see here, this is from cache hit. Let me change this a little bit to prove it is a semantic search. Make me try with the Redis joke. I hope this will again hit cache. Let's check. See, even if we are sending with a different message, which is semantically same, so it hit the cache and we got the cached response. Now let me hit the API with the totally different message. Explain Spring AI. Let me ask it in a different way. What is Spring AI? I'm not sure whether it goes to LLM or hits the cache. Let's send. Yeah, it is getting it from the cached response. Now I have added these two logging levels. To log this score, let me clear the terminal and hit the API, which we already have the cache. Do you see this score? It is more than 0.9, right? So it's going to hit the cache. This covers the concept of Redis cache use along with the LLM call. If you have a use case like there are some questions which are frequently asked and you don't want to hit every time LLM and incur the cost, in that case you can use this cache and responses will also be faster. This concept looks bit advanced. Hope you will find this useful for some cases. This isn't memory in traditional sense. It's a cost optimization. With this, we wrap the lesson, chat memory. See you in the next lesson.